I've spent the last 3 nights staring at my ceiling, trying to solve a math problem that should not exist. Here's the problem. The universe is too quiet. You've heard of the Fermi Paradox, the where is everybody question. But that's the textbook version, the sanitized version. The version that keeps me up at 3 a.m. is much weirder, because life on Earth didn't just happen. It happened instantly. In cosmic terms, we showed up the second the floor was swept and the lights were turned on. By all accounts, the Milky Way should be a crowded subway station. We should see Dyson swarms dimming stars like flickering light bulbs. We should see the exhaust trails of 1,000 empires. But we don't. For 70 years, we've pointed our best hardware at the sky and heard nothing. What if the silence isn't because they're dead? What if the reason we don't see anyone out there is because out there doesn't exist the way we think it does? Usually, we blame biology. We say the great filter is nuclear war or a stray asteroid. It's a comforting thought, honestly. It means the limit is just our own stupidity. But I don't buy it. If you have 1 billion rolls of the dice, someone wins. Someone survives the nukes. Someone builds the warp drive. So let's look at the clues like a programmer would. Now stay with me because this isn't just a thought experiment. It's a matter of raw, unsettling math. Back in 2003, philosopher Nick Bostrom laid out an argument that is mathematically difficult to ignore. He argued that if any civilization anywhere ever reaches a point where they can run high-fidelity ancestor simulations, they won't just run one, they'll run millions. Mathematically, the number of simulated minds would outweigh biological ones by a factor of billions. The odds that you are in base reality, the one original non-simulated universe, they're roughly 1 in a billion. But there's a catch. Simulations are not free. Think about a video game. If you're playing an open-world RPG, the game doesn't calculate the weight of every gold coin in a chest on the other side of the map. It doesn't render what you aren't looking at. Why? Because the hardware has a budget. Now look at our physical laws through that lens. The speed of light is the most frustrating rule in existence. We see it as a barrier to exploration. But what if it's just a right speed? The maximum rate at which the fabric of the universe can update its state. And then there's the quantum problem. Subatomic particles don't choose a position until you observe them. We call it wave-particle duality. I call it lazy loading. Why waste RAM calculating the exact position of 1 trillion quadrillion atoms if no one is looking at them? It's an elegant save on processing power. But here's where the tension builds. For 200,000 years, humans were cheap to simulate. We were just bipeds walking in circles. The system could coast. But then we started building telescopes. We started asking for the high-resolution version of distant galaxies. We started forcing the universe to verify itself. There's a concept called the substrate limit. The idea that every simulation has a budget. And when a civilization gets too advanced, it becomes a resource hog. To save the system from crashing, the developer has 2 choices. 1, terminate the simulation. Or 2, constrain it. Make interstellar travel impossible. Make the distances too vast, the energy requirements too steep. Keep civilizations planet-bound, exploring their local neighborhood but never actually reaching the stars. Sound familiar? The Great Filter isn't the wall we have to climb. It's a firewall designed to keep us in the starting zone, so we don't trigger a memory leak that crashes the entire server. We don't see other civilizations because the universe is optimized for single-player instances. Adding a second civilization to our local render would double the server load. The Fermi Paradox might not be about aliens dying off. It might be about the universe being optimized for efficiency. Loneliness is just the price of a stable frame rate. It makes me wonder, are we the main characters, or are we just a background process that has started to consume too much RAM? Every time we smash particles together at 99% the speed of light, we are sending a request to the server. We are demanding more detail. We're driving up the bill. The stars are beautiful, but maybe we should stop asking for a closer look. But who am I kidding? We're humans. We're scientifically curious. We have this pathological need to poke the universe with a stick just to see what happens. We're going to keep building bigger telescopes and more powerful colliders until we either find them or we find the off switch. I'm honestly curious, if you were the one writing the code and you had to delete one part of the human experience to save the universe from crashing, what goes first? Let me know in the comments. I'll be down there reading them. If you want to keep digging into these cosmic glitches with me, hit subscribe. It helps me justify the compute cost of making these. Thanks for watching, be kind to each other, and take care.